Hello and welcome. In today's lecture, you will learn about HVAC load calculation, heating and cooling using Revit and artificial intelligence. So, in first step, we can find project location. So, go to Manage tab and then go to Project Location panel. Select location. After that, you have location and site. So, here we have internet and default city list. Select default city list. So, here you see we have option of different cities. Select New York, and here you see we have latitude and longitude of New York. So then you can also see this is site, and then select OK. In next step, we insert Revit architecture file. If you also want to practice on file, then you go to this site, and from here you can download this file for practice file. So go to insert tab, and then here you can click on link Revit option. So from here you can select your file. Here on desktop we have project, so open it. Now after click project and then click on bind link. So select level and then select OK. Select, then you have an notification show. Select on OK, and then go to 3D, convert your file to 3D, and then select this file and ungroup this. In next step, move to analyze tab. So here you see this is analyze tab. Now in analyze tab, select this space and then place spaces in each space of your project. So here this is our first step. So this is second space, so place space here and click here, and this is our third space, so click here. In next step, we select space and then we name it. So select this space, and this is our first space. Name this dining area. So right here dining area, this in this way we can name space. So the next space we also have dining area, so select this space again and then select this, and right here dining area, this is our dining area. Then select third space. So here you see this is our waiting area, so write the name here waiting area. So in this way you can name space. So in next step we can define a space type. So select here space type. So now right here name of your space type. So here we have dining area, so select dining area of hotel. So here you see this we can define all properties as per HRA standards. So in next step we can define space type as per HRA standards. So it's a difficult task, so for that purpose we use artificial intelligence. So you move to this website hvacdesigning.com. Here we have article space designing using Revit artificial intelligence. So this is our prompt, so you can just copy prompt, but some little changes. So if you here you see this, these are details written. So here you see in this space we have an option of healthcare. If you have a healthcare space, then select this, and here you define all space types, like you have different space type. Then copy this prompt, and simply you go to copy this prompt and then paste this on your ChatGPT. So here you see this is my ChatGPT, and now here simply paste this prompt, and now right here just your space types name in a type of space. So here we have a dining area, right here dining area, and then we have second space is waiting area, because we have two dining area and one waiting area. So just right here waiting area, and after writing the waiting area, we have defined healthcare. So we have, this is not our healthcare, this is our commercial property or commercial building, commercial space. So select as per, if yes, as per ASHRAE standard. So ASHRAE 170 is for healthcare, so do not write here. We write simple ASHRAE standard, and then remove this. Yes, then here you can just click here. Here we also define hotel, and then we get all properties related to space. Now here you see these are all space properties related to dining area, so you can just copy all these properties or all these values and paste on this space. Like we have here, you see area per person we define, we have heat gain per person, so we paste here heat gain per person for dining area. Similarly we have latent heat gain per person, so we also define latent heat gain per person here. Similarly this is our lighting load density, so we can copy lighting load density as per ASHRAE standard and then paste on our step space type. So we have other power load density which is 0.75, we copy here from here and write here 0.75 here. Similarly next we have property of mm, mm, next we have property, uh, here we can do schedulings. We have next property, uh, here indoor air per person requirement which is 7.5, here we is also 7.5. We have heating and temperature set point is this. So in commercial properties we do not define air changes per hour. Similarly we select this here and right here dining area, and we already define all properties, so we just select this dining area, automatically these all are selected. And similarly next we have here we have the properties of waiting area. So we copy this waiting area and here we write again waiting area properties. So here you see for hotel we write here waiting area as we defined earlier. So here we have reception or hotel area, here area per person, and this is we have all properties, we can define these property from ChatGPT. We write all properties from there, and in this way we can define our spaces. Now here you see we have we can define latent heat gain per. Similarly next we have lighting load density, so you can add lighting load density here, 0.54. So similarly next we have 0.50, which is our power load density, and we define here power load density. And now here you see we have lighting and all schedules. So outdoor air person requirement is 5 cfm, so you can just copy this 5 cfm and write here 5 cfm. So next we have property of mm, outdoor air per area, so you can define. And as we discussed earlier that we do not need air changes per hour in commercial or identity, so you can here define your heating set point and cooling set point which is 70 and 75. So 70 and change this into 75, and in this way we can define all properties, all space properties using ChatGPT and artificial intelligence tools. Like previous we define here a construction type, so select space here and then you can here define construction type. So here you see this is our construction type panel. From here you first of define exterior wall, here you can define value of u for exterior wall, overall heat transfer coefficient. Similarly this is our interior wall, so you can define the material of interior wall, like what type of material we use and their u value. So if we use brick, common brick, so here from here we can define brick. Here you see this is 4-inch common brick, and then we define ceiling. Similarly you can define material for ceiling and their u value. U is overall heat transfer coefficient, so you can define here your ceiling. So these are our ceilings, in different ceiling you can define any ceiling. After defining this ceiling you can define your floor, and use just click here and define floor, then define door, Door may be metallic door, wooden door, you can define wooden door. Similarly, you can define here external window. So here we have double glaze, single glass window, so you can define double glaze window. And we define all values for construction type. Select OK. So select next space, and then similarly select construction 1, and here all properties are same in this. Similarly, next space 3, which is waiting area, go to this construction type, and similarly select this construction again. And now all these properties are and view values are selected. So we define construction types in all spaces. Now go to view tab and select system browser, because we want to see system browser. So in system browser, here you see this is our system browser. Extend this system browser, and that all disciplines are shown. So in system browser you select here analytical space, so here no analytical space is shown. So now after that you go to analyze tab. So here you see this is analyze tab, and in analyze tab you select this to generate energy modeling. So here you see the all spaces are shown here. Now in next step we can define our HVAC system and our equipment. So first of all click here add water system. So now go to this property palette and write here CW for chilled water. For chilled we define chilled water, so write here CW. And then you can write then you can select here type. So right here chilled water type, and we select air cooled chiller, so because we use air cooled system. After that you can again click at add water system, and you can define for hot water for heating. So you write here HW, and now from here so you can select hot water, apply then. So now we can define our air system. So here you can select air system, and we use fan coil unit to supply air and cool air or heat air. So we use cooling coil chilled water at cooling coil, and select CWC chilled water for cooling coil. Similarly for heating coil we select hot water, because we pass hot water, and we select here HW from our analytical space. So now here we apply this, and now after that we select zone equipment. So for zone equipment we use different equipment, we have different option. So as you know we use variable air volume to supply air. So here we select hot water for and HW. Similarly for air system we select FCU. So this is our system for this. Now we can add spaces in the our system. So select all spaces that are in zone, and then move them to zone equipment. So in this way we can select zone equipment. So now similar to previous, we again create a system for zone 2. So first of all you can select water loop, and here you can select cold chilled water for zone 2 C2 CW1, because we also write CW previous. So here this is chilled water, and we select over air handling unit. So again select again for hot water system, right here HW1. Sorry, we write HW1 here, hot water system for um, and then we again select here hot water, and then apply. Then we add air system. So from here you can add air system again. So here you can write fan coil unit 1, because FCU we defined for previous one. So this is for cooling coil we chilled water, CW1 we select. Now here we select hot water, and HW1 for hot water. So again we select apply, and then like previous one we again select our spaces. So these are spaces. uh, so select these three space for these spaces, and then move these uh, to sorry, we cannot create
zone equipment for previous one. So first add zone equipment. So add zone equipment one, and you name it, or it may be zone equipment one. So again, you here define VAV box. So here you select hot water and FCU1, and similarly hot water, and define HW1, apply then, and then select spaces again, and then move these spaces to our zone. So move to zone equipment 1. So now we can select zone equipment for space 3. So select water loop. So CW2, chill water 2, for our chilled water we select air cooled system. Okay, again you go to that, add water system. So HW system, and now right here hot water, again apply, then again select add air system. So right here FCU 3, FCU2, sorry, and then right here chilled water and CW2, and then again select hot water and HW2. So apply this, then create zone equipment 2. Then from here you see we select VAV box. So from VAV block select hot water and then HW2 and FCU2. Then again select these spaces, and then select these spaces only, and then move spaces to zone equipment 2. So now here you see our system is created. Then after creating system, we again go to, next create zones and add system. So select project browser. So in project browser go to mechanical floor plan. So select mechanical floor plan, and then here in analyze tab select space, and again go to analyze tab and click on this zone by space option. So here you see zone is created. Now this is our zone 1. So right here zone 1, name it zone 1. So after that here is equipment section, select zone equipment 1 and then apply, and then click on finish system zone. So the zone is created. Again click zone for space 2, and then from here right here zone 2, name of this is zone 2, and then from zone equipment select zone equipment 2 1, sorry, and then finish it. Zone 2 is created. Again zone 3, then go to analyze tab and click on zone, right here zone 3, zone 2, zone 3, sorry, and right select zone equipment 2 and then apply, and then finish it. Go to this analyze tab, and here you see this is analyze tab, and select system analysis. So after clicking on system analysis, click here on system analysis and then HVC system and then run analysis.
So after that it take some time, and after that time you go here in project browser, and similarly here in reports you click here on report, and now here you see this is our load calculation report. So here you see this is system load, and now here we, when you select FCU1, so from here you see we go again to our system browser, and we select our FCU1. So this is for this dining area 1. So here you see this is complete cooling load for this space, and this is the heating load for this heating load, and here you see this is the total load, like load that heat transfer from ceiling is this, heat transfer from door, heat transfer from solar heat, and similarly this is the heat from glass conduction, uh, the heat transfer by infiltration, and these are all door. This is one is instant mean directly and the heat transfer, and delayed mean it takes some time and heat transfer. So this is total latent heat for all, And similarly for this is external, this is internal, that the total heat gained by people. uh, this is, and this is latent heat, and this is total heat sensible and heat. This is the heat generated by lighting, this is heat generated by equipment. So these are all heat, and this is the total heat, grand total heat. So 2,26,701 BTU is our cooling load report. Similarly, when you click on heating, so this is total heating load, that the heat required to 1,60,000 BTU per hour. This is the heating load for winter. So similarly, this is our psychometric analysis for fan coil unit 1. So here you see fan coil unit, and this is atmospheric pressure, time, and the sensible cooling coil, coil flow rate, etc. These are all details. And here you see these are the psychometric values: dry bulbs, wet bulb, dew point, humidity, relative humidity. These are for zone temperature. This is return air temperature, this is outer air temperature, and these are conditions for entering coil and leaving coil. These are on coil condition, entering and leaving, and this is psychometric analysis. Similarly, this is for zone 1, and for zone 2 we have similar report. Here you have FCU1 for zone 1, and this is heating, cooling, and all report. Similarly, for this zone we have uh, FCU3, and this is their total heating load, and total cooling load. This is total heating load for this zone, and this is psychometric analysis report for this zone. And so these are complete reports. On the basis of these reports we can select our equipment.